We'll look at one more example of error, but in this case, we're going to look at error in terms of by using our calculator. So we have a Taylor polynomial, x minus x cubed over 3, and this Taylor polynomial approximates arctan of x. And we want to know how, we want to know the values of x. What values, find the values of x for which this polynomial approximation will approximate my actual function arctan of x to 4 decimal places. Well, what is this really saying? Well, this is saying I want to find the values of x such that f of x minus p sub 3 of x, that error is within 4 decimal places, so that this difference is less than or equal to 0.0000 4 decimal places 5. Just to, for later references, this is 5 e to the negative 5. Okay, so how do we do that? How am I going to find that? Well, let's in our calculator find, let's put this into y1, and let's put this into y2, and let's see when that is in fact true. Okay, so getting out my calculator here. In y1, we're going to put in the absolute value of f of x, which is arctan of x, so second tan of x, minus, parentheses, minus p sub 3 of x. Well, p sub 3 of x is x minus x cubed divided by 3. Close the parentheses. So now we found the absolute value of the difference, and that's the remainder. And we want to know for what values of x will that remainder be less than 5 e negative 5. So this is going to be a very, we're going to have to be very careful about our window here to find this intersection. So let's change our window, and let's change our window so that the y values are going from negative 6 e negative 6. Sorry, make that negative 5. And then going up to 6 e5. And why am I choosing these values? Well, 6 e5 is just bigger than 5 e5. Sorry, 5 e negative 5. And since we're talking about the absolute values, I want to capture both the negative and the positive of that. Okay, so I think we should be good. Let's graph it. We might need to change the x values. Ooh, so we definitely need to change the x values. So in this region here, that's where my f of x minus p sub 3 of x, that's when it's less than 0.005. So, but we need to zoom in on that a little bit. So let's change my window to look from, let's go negative 0.5 to 0.5. And what we see is for all values of x from here to here in this range, for all those values of x, um, my polynomial function, or rather the error of my polynomial function, f of x minus p sub 3 of x, the error is going to be less than 0.0005. So we need to find these two values. So let's do a second calc intersection. And there's one of our intersections at 0.191. So one of our intersections is at 0.191. And then let's find the other intersection. Well, let's find the other intersection. Let's go back to our calculator. Once again, second calc intersect. Now we need to look over here. And symmetric. So we have negative 0.191. And so what we just showed, for these values of x, for x equal to that range of values, my polynomial approximation for arctan, my third degree polynomial approximation for arctan, will give me an error that is within 4 decimal places. So that gives me a range of x values for which I can appropriately use my Taylor approximation. That's it for this. So this would end our study of series and sequences. It's a big topic, a tricky topic, a heavily tested topic in the BC exam. So it might be a good idea to go back and look at any of the topics in this chapter that are not yet solid for you, and make sure that you spend a lot of time over the next couple of weeks continuing to review and study all these topics. All right, that's it.